Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an example to illustrate how to use the empirical rule. Alright, so if you remember the empirical rule, quick rundown, mean equals median 50% on either side. Sorry, my puppies are getting a little loud there. And then if you add or subtract one standard deviation, you get 68% of the data. And if you add or subtract two standard deviations from the mean, you get 95% of the data, and then 3 of them get you right out here on the peripheral. That's why the z-scores only go to 3.5. Z-scores are pretty much indicative of how many standard deviations we are. It's a way of normalizing the data, because not every time will you get a data point that's exactly one standard deviation above or below. Usually in real life it doesn't work out that way. So let's just see how we would use an empirical rule. Let's take an example. Let's say that we have a normal distribution on your stat test of 82 with a standard deviation of 6. So that would be your mu, and that's your sigma. So what we need to do is come up with a couple problems. So what I want is, what's the proportion of the class I got below in 88? Proportion of the class I got below 70. And then we're going to do greater than 70. And then we're going to do in between 70 and 88. Oops. Jumped the camera. Alright, let's see it in action. First one, less than 88. Well, what we need to do for portion of the class that's less than the 88 is ask ourselves, how many standard deviations away from the mean are we? Then ask ourselves, in what direction are we? So if the mean's 82 and I add 1 sigma to it, where does that put me? Puts me at 88. What's the question asking? Below 88. So we want from here all the way to the left. That's what the question's asking. Alright, so what we can do is we can subtract 1 standard deviation from the mean, and we know that between these two blue vertical lines that there's 68% of the data in there. And if there's 68% of the data, that leaves 32. We get 100 minus 68 gives us 32% of the data. Okay. So now we have 16 here, 16 there. So if I want below 88, it would be this portion, which is 16, plus this portion, which is 68. So 84% of the class was below that score, raw score of 188, because it was exactly 1 standard deviation above. We were able to do this empirical rule. Alright, you guys remember the standard deviation was what? 6. So this difference right here is 6. And this difference, I didn't write the bottom value. If I take away 2 and then 4, that gives me 76. And between those two values is the 68%, and then 32 outside divided by 2. Alright, let's go on to the next one. B was less than 70. So less than 70. 70 is 2 standard deviations of the mean, right? Because 2 times sigma is 2 times 6, which is 12. and 82 minus 12 gets us our data point that we wanted of 70. So we know that if we were to draw our normal curve, there's the mean of 82. If I go 1, 2 standard deviations, that's where I'm at 70. And I know that if I went up 2 standard deviations and added 12 to it, we get 94. And that there's 95% of the data there in between those two values. So what you can do then is you can do 100 minus that 95 to determine how much is left for the peripheral parts. That's going to be 5%. Divide by 2 means that there's 2.5 here, 2.5 there. So what we do is we add this portion and that portion. No, I'm sorry, I lied to you. We wanted less than 75, right? So we just take that 2.5 and that's our answer. Because we want this direction. So equals 2.5%. Alright, and then if we were to look in between the two values, then what would happen? Oh no, greater than. So greater than would just be 1 minus that 2.5. Would be the easiest way to use the complement rule. If I want greater than 70, I do 1 minus the probability of x is less than or equal to 70, which is 1 minus 2, or 100 minus 2.5. We're doing percentages. And that's going to be 97.5. Okay. The other way you could have done it is just added the two parts here, the 95 and the 2.5. Try to understand it pictorially as well as logically. And then D was in between the two values, so what was the other one? 88. So 88 would give us, just take the difference between the two. So it would be, what was it, 84% from less than 1 minus 2.5%. So that would be 81.5%. Okay, so what we did on the curve there was, here's your normal curve. We wanted in between these two lines that I just drew, the 88 and the 70. Actually, since it's 2 standard deviations to the left and just 1 to the right, I have to be closer to the point on the right. And also 82 is closer to 88, however you want to look at it. So if I want it in between these two, what I have to do is I have to take everything to the left of this and then take out that little portion of that. So we do that 84 minus that 2.5 to get the 81.5. Alright? The best way to become familiar with this, I didn't do the most obvious one, but sometimes it still gets people. If they said proportion that's greater than 82, or if it was less than 82, the answer is going to be 50%. And if they give you an equals, it's always 0. There's no probability associated with a equal sign in a continuous distribution. All right. So practice, practice, practice. I hope this has clarified things a little bit. Thank you and have a nice day.